Welcome also from my side to the project update of openDuT. As you have seen or heard previously by my colleague from Tilo, openDuT was part of this car demonstration. So now I will give you some more insights, what is behind openDuT. Maybe some of you may already know some more details, but I have some updates as well. Maybe some things will be new for you then as well. So, did it work? Oops. Yeah, same slide, obligatory slide. Maybe I use it to just tell you a few words about myself. My name is Michael Renz. I joined MBTI about 3 years ago as a product owner, and I'm working in the openDuT project since January of this year. So, yeah, that's about me. And basically, maybe something else. I was also working in the connected car environment. So we were developing the Mercedes-Benz Intelligence Cloud together with the colleagues from research and development. And now I'm focusing more on the testing and validation tooling and car development platforms. What I'm going to tell you about today is the following topics. First, what drives us. I will tell you a bit more about what we are looking at when we are looking at the openDuT development, the openDuT project. Give you a brief overview who is involved in this project. We are not doing it all alone. We have some partners involved. And summarize what is openD all about and what is new about openDuT. This might be the most interesting part for some of you guys. And I have also a typical POC example that I would like to show you, how we use it for testing the CAN bus integration using the openDuT network. And last but not least, a brief outlook, what else we are planning to implement for the openDuT. So, what drives us? We think the electric architectures in the vehicles are changing. Recently there were lots of ECUs in a vehicle, more than 100 ECUs. Now it's reducing again. We are having more and more bigger ECUs, more powerful ECUs in the vehicles, accumulating more and more functionality. And that means also those few powerful ECUs are very highly demanded, especially in early development stages. And rare ECUs, especially for people that want to test their features, their distributed features across multiple ECUs. This is a hassle sometimes to get all this equipment all together to be able to test it. So we are thinking, we need to challenge the way how we develop and test automotive ECUs and software for those ECUs by always challenging the way we do it, by thinking differently. And the idea came out, yes, we want to test ECUs around the world in a transparent network, bring them all together in a network. And how do we do this? We do this with openDuT. openD will provide a framework that will be able to integrate those different ECUs in such kind of network, will provide means for test automation and validation of the functionality of the different ECUs. That's being said. Who is involved? As I said, we are not doing this all alone. We have different partners that are also member in the SDE community, like AVL, Carriot. I better go here for the sound. ETAS, EAV, and of course Mercedes-Benz Tech Innovation. We are developing this in conjunction, close development with our partners from RD. Colleagues here are complaining about the sound, but But I learned over the Teams is much better than here in the room, but okay. Well, you also find the link down there underneath the slide here. You can go there and look up the details about the Eclipse project for openDuT. And since we are being funded by some public supporters, one is the European Union, and together with the German government, the BMW car is financing and supporting this research project as well to some extent. We are happy that we have this co-financing in this project. So let me summarize what is openDuT all about. Is an open platform, a framework that will enable integration testing of ECUs, no matter where they are located. We have a validation support. You can run test cases, automated tests on this openDuT network. And of course, this network and this configuration can be set up repeatedly, reliably, and in a secure way so that you can have regression tests that work the same as you had it earlier times when you set up the network. And of course, one important topic is it enables you to have the integration or sharing of ECUs between OEMs and tier 1 suppliers or any other supplier so that you can share the resources in an efficient way. So let me go into what's new, but first maybe a few more details about the openDuT components. It has become quite sophisticated framework with a lot of applications. Well, it went public, the first topic, on the github.com page in December last year. So everything, all the applications that you'll see listed here are available in the public repository. And you can look up the code. Everything is coded in Rust. So as we have seen earlier, Rust is the language to code applications nowadays. So you will find familiar code here. Maybe a brief overview about the components. You could see here on the chart on the left side, we have a central component called CAR. Some people were quite creative when they created those acronyms here. The CAR is the management service that orchestrates the network and distributes the configuration of the network and deploys it, undeploys it, and creates the connections between each of the devices. The devices are connected to our edge-GARs. This is an edge component, and those edge components runs on some hardware device like a Raspberry Pi or some device that my colleague Thilo just showed, the embedded device, and makes the connection from the ECU and the different communication channels the ECU has, like a CAN bus, automotive Ethernet. Well, that's the only two that we support at the moment. And then in order to handle all these configurations, we have Lea. This is the front end, is a web front end, also coded in Rust. And Clio is a command line interface that enables you to integrate it in CI/CD pipelines and orchestrate the configuration in an automated way. Theo is a test environment that we also provide to help developers joining the project to get familiar. It's an easy kind of setup of all the applications that build up the framework so that you can run it and test it, play around with it. Documentation is available here on openDuT eclipse.dev. Please go there, check it out. For CAN bus, here is mentioned again, we use also an open source framework from Cannelloni based on the socket CAN, integrated in our edge-GARs. Later on, we also have some discussions about the license. Cannelloni is licensed under GPL2, and our openDuT network is licensed under Apache 2. So we have to check what is allowed so that we don't get in conflict with the different licenses that we integrate here. Just a closer look how that interacts within the openDuT framework. We have on top the management service with the car management server. We use Network as an open source technology to configure the VPN connections. Each of the peer devices opens a VPN connection for the automotive buses connections. And yeah, underlying under the network technology, we have WireGuard as the VPN technology. And underlying that, we use some GRE, some encapsulation protocol that will also package the CAN frames before it gets transmitted in the VPN channel. We have different APIs on the management service. It's not, as you may expect, a REST interface. It's a gRPC interface. That's why, it's not that easy to use, but that's why we have those client applications like Clio and the front end. Also mentioned here, test management will be part of the management service that we can orchestrate some tests. And the test execution engine can run on the different peers launched by the EDGAR devices. But I can explain that a little bit later in more detail. Before I continue, also you see here there's a firewall. So one important aspect is that we can integrate devices across firewall borders, meaning company borders. And this is also established by using a kind of turn server on the management server side to bridge the VPN communication. Then we have managed mode now live with openDuT. That means every configuration that we do via the management service can be deployed to all of the EDGAR devices. We can do this easily by providing a setup string. When you go to the front end of CAL, you can retrieve a setup string containing client credentials, client IDs, information where to connect to the server. So you just take that setup string and feed it into the EDGAR when you run the EDGAR application on your peer, and then it is basically all set up and it connects automatically to the server. Authentication was also added recently so that all the clients will have a authentication with a client ID and client secret that is managed in a Keycloak server, also included in the management server. And that's basically the rest I already told you about. We have the integration into CI/CD pipelines with the Clio command line interface. That is a very powerful tool. It can do basically everything that you can do with the front end. Then a little bit more information about Theo, the test environment. Is a automatically created setup in a virtual machine. openDuT runs basically best on Linux. You don't have a way to run it on Windows, or you always need some virtualization on Windows for openDuT. And we have that set up here using Vagrant that will spin up a VirtualBox with a Linux operating system in it and launches all the applications which are Dockerized within that virtual machine. As you see here, also the Keycloak or Firefox browser to run the front end when you want to access it. We can operate the test environment in two modes, in normal mode and development mode. in development mode, you can use it to develop your server components, like as a drop-in replacement. You have it on your host, you develop it on your host, and it connects to the other services inside of the VM. So it's easier to develop your server components. Then another feature was the test execution or test executor. Edgar was extended to launch different containers like Docker containers, Podman containers, which will be, we have it so that, that you can configure those containers in the front end as well. You see there a configuration mask where you can define which container to download from which repository, and you can also define which parameters you want to pass into the container to the application that is being executed. So this is fairly new that we support that, and this is also a mechanism to basically introduce all test application run test executions within the framework. Another topic that we recently added to also Theo, of course, is the operation support. Since this is an entire distributed system, we need some means for tracing and monitoring of all the applications, what is going on in the system. So we added, based on OpenTelemetry, those logging, monitoring, and tracing tools as mentioned here. Then I have a brief overview of a typical setup that we are using to test the campus integration. We have one peer on one side with an Edgar installed, connecting an ECU, the device under test, via the CAN bus. On the other side, we have a test PC, also a Linux-based computer, running an Edgar service as well, Clio, and it connects through a virtual CAN interface, which is connected to the CAN interface on the other side. And this is defined by configuration on the management server. And when you deploy this configuration to the system, it automatically creates this WireGuard tunnel between those two peers and connects basically the virtual CAN to the physical CAN of the ECU on the other side. So they can communicate directly, and you can run test scripts on your test system over the CAN bus, and also evaluate the results, of course. The results of the test script can either be reported to any kind of repository, like log files or other data that you collect during the test execution. And in another step, the idea is that we will integrate it into CI/CD. Like if you have a GitLab testing pipeline, we will have a GitLab runner that connects to the pipeline, uses Clio to launch the test script and deploy it to the edge device, in this case, the same computer, but it can also be distributed, of course. And this is a typical setup that we are currently evaluating and exploring in more detail. And I think this is similar to the setup that we just saw in the vehicle. The vehicle would have been over here, and the ECU that Thilo showed, it would be this device here, and is connected via this tunnel to the PC that Stefan had here in the room. Okay, what else to expect? We've still a lot of things to do. We are a small team, but we have to prioritize. We always face also, implementing those features first that are most important to our colleagues that want to do POCs with openDuT. And those are some other topics that we still have in the pipeline. like some contributions to be expected from our partners, EAV and AVL, all around the test management and test execution tooling. Authentication is pretty much completed. Only some few optimizations still can be added. But authorization is something that we need to think about. We need some role-based access control to the different resources. And this is something that we still have to provide. Also, persistence is something that we need to add to our management server. Carl is currently only storing everything in memory. That means if you deploy it or restart the management server, all your configurations are gone if you don't have them saved in some local configuration files that you use, for example, with Clio to feed it in again. But we want to also persist it with a database in the future. And with the persistence, we can also do better status tracking of the different cluster components and peers. This is something we want to improve. And also we want to prepare the server components for being cloud ready, provide some Helm charts that it can be easily provisioned in the cloud environment. And of course, last topic is we want to connect not only real ECUs in the openDuT network, we also want to use virtual ECUs, combine them with the real ECUs as well. Oh, that's the topics that are outstanding. If there's questions, I'm open for questions now. Thank you for attention. Yeah. Yeah.
I think in slide 8, you've shown several buses connected to several ECUs at the same time. Do you have some concept to synchronize them so that you can, for example, replay them in the same speed and the same timing, in case this is important? So all buses are sending and receiving asynchronously and have different clocks, and can you somehow get this together based on one clock so that you have the exact relation when each message has been received?
That's actually a good topic that we have not really thought about in detail. I may have to discuss that with the other colleagues what they think, but I was not thinking about this timing topic at this point. You think this might be a topic that needs to be, or is a critical topic that you need to see when each of the different partners send their CAN bus messages, which clock, or you need some clock synchronization that everyone has a synchronized clock, you mean? Mm-hmm. I would assume that we will have some time server somewhere that all the peers will connect to, that they synchronize their time, that they all have the time synchronized. And then I would assume that also the ECUs that are connected to those peers will be synchronized with the same time schedule somehow. But I will have to look a bit closer into that topic, of course.